In our last session, we learned how to predict the solubility of salts using the charts. Now we're going to apply this to what are called precipitation reactions. In precipitation reactions, what we have are two salts that are water soluble, such as sodium hydroxide and ferric chloride, and we mix them together in water solution. And when we mix them, we want to see if a reaction occurs. The rule is that a reaction occurs if a precipitate forms. Okay? A reaction occurs if a precipitate forms. Okay? If no precipitate forms, then no reaction has occurred. So let's take a look at our reaction at hand. What we're going to do is, in drawing the products, is we're going to interchange the ions. Okay? So I'm going to combine the sodium with the chlorine. When I do that, I get sodium chloride, and then I will combine iron with hydroxide. Remember, the iron was the +3 as designated by the 3 on the chlorine. So that gives us ferric hydroxide. And looks like the equation is unbalanced, so I can put a 3 here and a 3 here to balance it out. Now I want to use the table to see if either one of these is water insoluble. So let's take a look, first of all, at the chloride. Okay, so there's the halogens. I see that all chlorides are soluble except to the right there, and we do not have an exception. So we can write AQ for sodium chloride. That's very water soluble. Let's go next to that hydroxide. Hydroxide, the top row. All hydroxides are insoluble except to the right, and iron is not an exception. So this one here will be a precipitate. So we write an S with it. So since we have a precipitate, then that means that this reaction occurs. Okay? Now, if a reaction occurs, what we will want to write out is something called the Ionic Equation. In the Ionic Equation, we're going to break up everything that's water soluble into its ions. So let's start here. So that 3 and AQ, so we have 3 Na plus 3 hydroxides, which is OH minus, plus we have Fe3 plus, we're breaking this up because it's water soluble, plus Cl minus, but we have 3 of those from the subscript, so we can write that there. On the product side, we have 3 sodium cations and 3 chloride ions. Then lastly, since this is water insoluble, we will leave that ferric hydroxide alone. And this is what's called the Ionic Equation, where it's showing all the possible ions that form in the equation. The last thing that we do is we write the net ionic equation. In the net ionic equation, we look for the same ions on both sides of the arrow. So I see I have 3 sodiums, so I can cancel those out. And I have 3 chlorides, so I can cancel those out. The ones we cancel out are what are called spectator ions. Okay? So our spectator ions are the sodium and the chlorides. These are not involved in the reaction because they're ions on both sides. The only thing that's involved in the reaction is my 3 hydroxides plus my iron 3 plus forming ferric hydroxide as the solid. So this is my net equation. These are really the only ions that are reacting. When they react, they come together to form this precipitate. And thus we call this the net ionic equation. Okay? So be able to write an ionic equation, be able to write the net ionic equation, and be able to identify spectator ions in these kinds of reactions.